Hello students, by the end of the video you should be able to say I can solve volume and density problems. So this lesson is actually going to be a little more involved. We're not only going to solve volume and density of different objects, but we are going to be solving problems where you will need to apply concepts of volume and density. Let's take a look. Let's first define what volume is. Volume is defined as the space that something takes up. Right? We've solved problems in the past lesson and in the past exercise where you had to find volumes of different composite figures. We have not talked about this idea of mass yet, though. Mass is it's the amount of substance that something takes up, right? It's the stuff that fills up the volume. So substance that make up the object, in other words. Although weight and mass are not the same, mass is often related with weight and have the same units. Okay, in the metric system, when you get your weight taken, your weight is often measured in kilogram. That is actually the same as the mass, right? I don't want to get into the whole physics concepts, okay, behind this, but mass and weight are actually two separate things. Okay, if one were to be really, really accurate, let's say if a person weighed 45 kilograms, the actual weight shouldn't be kilograms. It should be 45 kilograms times the rate of acceleration due to gravity. But anyway, I don't want to get into too much detail of that. 45 kilograms is actually the mass of the individual, okay? Which brings me to the next concept here, which is density. Density is defined as the amount of mass divided by the volume that the object takes up. Now, the smaller the volume and the larger the mass, the greater the density. Let's take this example here, right? Both objects have the same radial measure, which then would imply, what about their volumes? If both of these objects here, okay, is that of a sphere, then the balloon and the bowling ball here would have the same exact volume, right? Because they have the same radial measure. If they have the same volume, right, one can argue that these two things will take up the, not argue, but one can suggest then that these two things will take up the same space. If that's the case, right, we clearly see the difference between these two. The bowling ball definitely weighs more. It has more mass. Not only does it have more mass, these two things, okay, are going to be different in terms of their density. The bowling ball will be more dense than the balloon will be, because of the fact that the bowling ball has more mass. The balloon is mostly air. Okay. Now that we've covered the concepts related to mass and volume and density, let's take a look at an actual problem right out of the Regents from January 2017, 3 years ago. New streetlights will be installed along a section of the highway. The posts for the streetlights will be 7.5 meters tall and made up of aluminum. The city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. The density of aluminum is 2.7 grams per centimeters cubed, and the cost of aluminum is 38 cents per kilogram. If all posts must be the same shape, which post design will cost the town less? How much money will be saved per streetlight post with the less expensive design? So there's a lot of information here, and don't feel overwhelmed with the amount of text that's drawn. It is really important for you to like decode and to write down the things that are important. So one thing's for sure, okay? What I would do if you feel overwhelmed, break down some of the ideas that are being presented to you right now. So you're dealing with a light post, right? And actually two different light posts, and you're comparing the two different light posts together. One of which is shaped like a cylinder. Where is it? It's right here. And another is shaped like a rectangular prism. And certain dimensions of the two are presented to you, okay? The posts have will be 7.5 meters tall. This is going to be the same for both of them. Okay, so what I'm going to do actually is blue here, okay, will be the one dimension that's going to be in common for both. And I'm going to separate or differentiate the items that are going to be specific for the cylinder and specific for the rectangular prism. So it says here the cylindrical posts have a hollow core with a 2.5 centimeter thick, right? And an outer diameter of 53. So the outer diameter is 53.4, and the aluminum will be 2.5 centimeters thick. And the rectangular prism posts have a hollow core with a 2.5 centimeters. Again, this is the same thing. So I'm going to use green here to represent the rectangular one. Okay, square base that measures 40 centimeters on each side. Okay, so this is 40 centimeters on each side, and it's a square base. The cost of the aluminum, so the quantity that's going to be the same is going to be in blue, is 2.7 gram. The density of the aluminum is 2.7 grams, centimeters cubed, and the cost of the aluminum is 38 cents. And what we're going to do is we need to take this information and compare which one will be the least expensive. So not only write down the information that I've highlighted here, but also I'm going to draw a diagram, okay, associated with this. So I have all the information from the previous slide listed out. I'm going to draw both a cylinder as well as a rectangular prism with a hollowed center, so which will look something like this, and I've labeled all the various dimensions. So both of these will have a thickness of 2.5 centimeters, right? Both of these will have a thickness of 2.5 centimeters. Both of these will have a height of 7.5. The outer diameter is 53.4. The outer edge here is 40. So what I will need to do in order to find the cost of either one of these posts, I will first need to find out what is the volume of aluminum here. And once I know the volume of aluminum, I can then determine the mass of the aluminum. And once I know the mass of the aluminum, I can then figure out the cost of the aluminum for each one of these designs. So let's do that. The volume of the cylinder can be found by finding the outer cylinder subtracted by the inner cylinder, which is in yellow here, and what I will be left with is just the hollowed core, which is in pink. So that's the plan, and this will be repeated for the rectangular prism as well. So to find a volume, okay, of the outer, same idea for the rectangular prism. So what I'm going to do with the cylinder, okay, is I know that the diameter is 53.4, which means the outer radius is going to be 26.7. The inner radius can be found by taking the outer diameter and subtracting it by 2 times 2.5. And then dividing it by 2, which is 24.2. So now I can find the volume of the outer and subtract it by the volume of the inner. So the volume of the outer and the inner can be found by replacing the values of capital R and lowercase r and the value of h. If I go through the computation, the volume turns out to be close to 300,000 cubic centimeters, which sounds like it's a lot, but it's okay because we're measuring with a really small unit of measure, centimeters cubed. Okay, so that's the volume of this cylindrical post. The density of the cylindrical post of aluminum is 2.7 grams per centimeters cubed. If I multiply that 2.7 grams per centimeters cubed with the volume here, what I will be left with, unit-wise, if you look at this, the units will cancel. Centimeters cubed and centimeters cubed will cancel. I will be left with just grams. So the mass of the cylindrical post will measure roughly 810,000 grams, approximately. If I find the cost of the aluminum, all I got to do is convert. The cost was given to me in 38 cents per kilogram. I need to convert this guy to kilograms. So in order for me to do that, I will need to divide by 1,000 grams. So 809,529, divide that by 1,000, I will end up with kilograms. And once I have the measure in kilogram, I multiply that by 38 cents. I end up with $307 for each one of these posts, for each one of these cylindrical posts. I will now need to repeat the process for the rectangular post. So again, take the outer minus the inner to get the volume. So the volume of a rectangular prism, all I got to do is just take the area of the base times the height. The area of the base, of the outer base, is 40 squared. The area of the inner base, what I will need to do is take 40, subtract it by 2.5, and I will need to square that. I will get 1225 as the area of the inner base. I take these respective area of the bases and multiply them by 7.5, and I will end up with 281,250 centimeters cubed. Knowing the volume of the rectangular posts, now I can find the mass of aluminum. So I'm going to take this and multiply by the density of aluminum, which will give me 759,375. I can already see that the mass of the aluminum is going to be less than the mass of the cylindrical post. But I need to figure out how much cheaper it will be, right? So I take this mass and I'm going to find out what is the cost of aluminum given this mass. So I take this, I need to convert it to kilogram and multiply it by the cost of the aluminum per kilogram. I end up with the cost of the aluminum to be $288.56. So now I can compare the two. The cylindrical posts will cost $307.62, while the rectangular posts will cost $288.56. The difference will be $19.06. If the town were to make thousands of these, changing the light post from cylindrical to rectangular will save millions of dollars.